Hello everyone. In this video, we will learn about the Markov models. Introduction to Markov models. We will learn some of the basic definitions first. Markov property. The future state depends only on the current state and it's not on the sequence of events that preceded it. State space. For example, a set of states, example sunny, rainy. Transition probability matrix is a matrix where each element Pij will represent the probability of the transitioning from state Si to Sj. Initial state distribution pi, it represents the probability distribution over states at the start. Stationary distribution, this is a distribution that remains unchanged as the system evolves over time. State space. It's a set of states, example sunny, rainy. It is represented as S1, S2 till Sn. Transition probability matrix. This is represented like this. P11, P12, which represents the transitioning from state 1 to state 1. This is the transitioning from state 1 to state 2. Likewise, it goes on. Then initial state distribution pi, it represents the probability distribution over states at the start. It's represented as pi equal to pi 1, pi 2, goes on till pi n. Stationary distribution is a distribution that remains unchanged as the system evolves over time. For example, pi into p equal to pi. It has a lot of applications and few applications are listed here. It helps in predicting the next word in NLP. Also used to model the stock prices and market indices in finance. It also helps in modeling the sequence of nucleotides in DNA. Also helps in modeling the sequences of phonemes. Now let us see some few problems to understand the Markov model. The first problem is we need to calculate the probability of observing the weather sequence sunny, rainy, sunny over 3 days using the given Markov model. These are the values given here. The transition probability matrix and the initial state distribution. In the transition probability matrix, this is for sunny and this is for rainy. So likewise, this is for sunny and this is for rainy. So the transitioning from sunny to sunny, the probability is 0.7. The transition probability from sunny to rainy is 0.3. From rainy to sunny is 0.5. From rainy to rainy, it's 0.5. The initial state distribution, that's for sunny state, it's 0.6 and for rainy state, it's 0.4. In this problem, we need to calculate the probability of the weather sequence sunny, rainy and sunny. So the values given here are the transition probability matrix and the initial state distribution. The probability of starting with sunny is pi naught of sunny, that is 0.6. It's the initial state probability. Actually, we need to find out the probability for the sequence sunny, rainy and sunny, which means we are starting with sunny and we are transitioning to rainy, and from rainy we are transitioning to sunny. The first thing is known. The initial state distribution of sunny is known. It's 0.6. The next we need to find out the transitioning from sunny to rainy, which means we need to find out the probability of rainy given sunny. The probability of rainy given sunny, that is 0.3. So from this matrix, we know that this is for sunny, this is for rainy, and again this column is meant for sunny and rainy. So from this matrix, if we want to find out the transitioning from sunny to rainy, this is the probability. So probability of rainy given sunny is 0.3. Now from rainy, we need to find out the probability of transitioning to sunny. So from rainy, the transitioning probability to sunny is 0.5. So probability of sunny given rainy is 0.5. We need to find out this probability. Probability of sunny, rainy, sunny. This is the sequence. So we are starting from sunny. That is the initial state probability. And we have a transition to rainy from the sunny. So that is what is given here. The probability of rainy given sunny. And there is a transitioning from rainy to sunny again, which is the probability of sunny given rainy. We need to find the product of these three probabilities, 0.6, 0.3 and 0.5. When we find the product of these three, the value is 0.09. So the probability for this sequence, sunny, rainy, sunny, is 0.09. Let us see the next problem. A person's health can be in one of the three states: healthy, sick and recovering. And these are the data given. Transition probability matrix is given and initial state distribution is given. There are two questions. Number one, we need to calculate the state distribution after 1 day. So after 1 day, the state distribution. And number two, for this sequence, we need to find out the probability. These are the values given. Transition probability matrix, initial state distribution. And if we want to find out the state distribution after 1 day, we need to find the product of the initial state distribution and the transition probability matrix. When we find the product of these two, the state distribution after 1 day will be known, and that is represented as pi1, and the state distribution after 1 day is 0.5 to 0.34, 0.14. This is the transition to day 2. Now to find out the probability of the sequence healthy, sick, recovering, we are starting with H. So probability of this H multiplied by the probability of S given H into the probability of R given S. So we need to find the product of these three probabilities. So 0.7, 0.3 and 0.1, which means let us consider this matrix. So this is health, sick and recovering, and this is the health, sick and recovering. The first thing is the probability of H. So the initial state distribution for health is 0.7 from this matrix. So this is the initial state distribution for healthy, and this is for sick, and this is for recovering. So this is the initial state distribution for P of H. So it's taken from this matrix 0.7. That's what is represented here. And probability of S given H, the transitioning from H to S. This is taken from this matrix. So probability of S given H. So transitioning from H to S. This is the value 0.3. That's what is represented here. And then probability of R given S. The transitioning from sick to recovering. Transitioning from sick from here to recovering. That's 0.1. That is what is represented here. So when we find the product of these three, we get the answer as 0.021. This is the probability of the sequence healthy, sick and recovering. Let us see one more problem. A machine can be in one of the two states, working or broken. And the given data are transition probability matrix and the initial state distribution. We need to calculate the state distribution after 3 days and the probability of the sequence working, broken, working, working. This is the data given. Now let us compute the state distribution after 3 days. This is the initial state distribution 0.95, 0.05. To compute the state distribution after 1 day, pi 1 will be equal to pi naught into p. That is the initial state distribution with the transition probability matrix. We need to find the product. And the value is 0.875, 0.125. So the state distribution after 1 day is known. To continue with the state distribution after 2 days, the formula is pi 2, which is equal to pi 1 into p. So that is the product of the state distribution after 1 day and the probability matrix, the transition probability matrix. We will be able to find out the state distribution after 2 days. That is the transition to day 3. Now state distribution after 3 days is equal to pi 2 into p, which is equal to, this is the state distribution after 2 days, the transition probability matrix, and the value is 0.81875, 0.18125. This is the state distribution after 3 days. Now the probability of working, broken, working, working. That is probability of working, that is the initial state distribution, into the probability of broken given working, probability of working given broken, into the probability of working given working. When we substitute the values for all these 4 probabilities, that's 0.95, 0.1, 0.4, 0.9, the value is 0.0342. This is the probability of the sequence working, broken, working, working. Thank you.